Okay guys, so today what we're going to be learning about are systems of equations. Okay, what is a system of equations? Well, a system of equations is a collection or a set of two or more equations involving the same set of variables. So for example, here is a set of equations and they both have the variables x and y. That would be considered a system of equations. Now, what are we going to be doing with these systems? Well, we're going to be solving them today by graphing. When we solve a system of equations, what we're looking for is we're looking to find the point where the two equations intersect, which means the point where they cross, because that point, the x and the y value, satisfies both of the equations. It will make both of the equations true. Okay, so the first thing we're going to do in solving by graphing is we're going to graph each equation. So in order to graph the first equation, I'm going to look at the y-intercept. Here's your y-intercept. That's going to be -2. So I'm going to go ahead and graph that right here on the y-axis. Then I'm going to look at the slope, the number in front of the x. Well, this is really a -1 here. So I'm going to go ahead and use that slope. And really it means that my rise is -1 and my run is 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Now, when you're graphing these systems today, what you want to make sure you do is you want to try to graph as many points as will fit on your graph. And even after you've run out of room going in the correct direction with your slope the first time, you want to try to go in the reverse direction to get some more points. So continue that pattern, okay, doing the reverse of this, which would be up and to the left, because you want to try to get to the very edges of the graph in both directions, okay? By doing this, you'll get the exact point of intersection, and it'll be easier to see where the lines cross exactly, okay? So after I have those points, I'm going to go ahead and connect them. Okay, so there's my first line. All right, now what I'm going to go ahead and do is take my second equation and graph it. So here's my y-intercept, and this y-intercept is going to be up here at +2 on the y-axis. And then here's my slope. My slope is 1/3. Okay, so +1/3, that means up 1 to the right 3. Now, I've run out of room going this direction, so now I'm going to have to do the reverse. So down 1 into the left 3. Now, I'm going to go ahead and connect the points on the second line. And now I should be able to see what's called my point of intersection. Okay. Now, the point of intersection is where the two lines cross, and this point of intersection is actually your solution. So this point, this ordered pair, is the point that satisfies both of the equations. If I plug in this point, it will make this one true, which means this side will equal the other side. And it will also make this one here, this side, equal the other side over here. So what is that point? Well, let's write down the ordered pair. So the solution to this first problem is the ordered pair -3, +1. Okay. All right, so let's take a look at the second equation. Okay, for the second one, I'm going to go ahead and graph my y-intercept. My y-intercept is -4, so I'm going to be looking at that number down here on the y-axis. Now, my slope for this second equation, this slope is +4, which means 4/1. So that would mean rise 4, 1, 2, 3, 4, run 1. Rise 1, 2, 3, 4, run 1. Okay? All right, so now I'm going to go ahead and connect those. And there's my first line. Okay, after the first line, I'm going to go ahead and graph my second line. So my y-intercept on my second line, +3. That's up here, at +3 on the y-axis. Now for my slope, here's my slope. My slope is 1/2. So that means I'm going to rise 1, run 2. Rise 1, run 2. Now I can also do that in the reverse direction to get some more points, okay, to lengthen my line. And so here's what my second line looks like. Okay, now I want to identify the place where they are intersecting. So they are intersecting right here at this point. That's going to be my solution. Okay, so my solution for this second problem is going to be +2, +4 is the ordered pair. Now again, what the solution means is if I plug in 2 in the place of x and I plug in 4 in the place of y, these two sides of the first equation will equal each other. If I also plug in 2 in the place of x here and 4 in the place of y here, these two sides will also equal each other. So I'll have two equations that are true, okay, where they're having the same value on each side. All right? Okay, so now what we're going to do is I'm going to have some volunteer pass out the note-taking sheet for today, and you guys are going to go ahead and practice doing some problems in the notes today. When I give you guys your notebooks back, you'll be able to staple the note-taking sheet into your notebooks. Okay, so let's go ahead and get that passed out. Okay, so everyone should be on this front side of their note-taking sheet. Okay, so we're going to go ahead, we'll do the first example together. Then I'll let you guys do the second example on your own, and then you can check your work. Okay, so let's go through this first example together. What's your y-intercept? Well, your y-intercept here is 2, so let's go ahead and graph that. Okay, and what is your slope? Well, what number is in front of the x? 1. Okay, so our slope here is 1/1, which means rise 1, run 1. Rise 1, run 1. So we're going to continue doing that. Now remember, try to continue that pattern in the opposite direction, going all the way to the other edge of the graph. That will give us the most precise line that we can get. Okay, now go ahead and connect. All right, so there's our first line. Okay, all right, so next what we're going to do is we're going to do our second line. So let's take a look. Your y-intercept here is +1. So we're going to start up at +1 on the y-axis, and your slope is 2. Okay, so if our slope is 2, that means my rise is 2, my run is 1. So rise 1, 2, run 1. Rise 1, 2, run 1. Okay, now I can also go the opposite direction, going down to left 1, and then I get a better idea of what my line's doing. So now I'm going to connect all of the blue dots, because those are my second line, and then I can take a look at where the two equations intersect. All right, so here's my intersection point. So this would be my solution. So now, in order to say what my solution is, I just need to go ahead and write what that point is. So what is that ordered pair? Well, it's 1, 3. So 1, 3 should be your answer there. Okay, next what you guys are going to do is you guys are going to try to do example number 2 right now in your groups and try to write down the solution right here, the point that you guys get for this one. Okay, so I'm going to give you guys a minute or two to do that. Okay, so let's take a look at what you guys got for number 2. Hopefully you plotted your first equation with your y-intercept at -1. Your slope on this equation, the slope here was -1/2, so that meant we were going down and to the right. So down 1, right 2, down 1, right 2, down 1, right 2. Okay, we can continue for some points going the other direction. So here's what our first line should have looked like. All right. Did you guys get that? Okay. So let's move on to the second line. Our y-intercept is -4. This one has a slope of +1, so that means we're going up 1, right 1. So up 1, right 1, up 1, right 1. And I can see already exactly where they cross, but I'm going to continue my line all the way to both edges just to make it really precise. And I'm going to connect. Okay, so hopefully you guys got that. Now, let's take a look at your point of intersection. Here it is. So what did you guys write down for your point of intersection? What was your solution? Okay, well, hopefully what you guys wrote down was +2, -2. +2 is the x value, and -2 was the y value. So that would be your solution. Okay, let's move on to example 3. Okay, in example 3, we're going to go ahead and graph these two lines, and we're going to see what the solution is. So let's take a look at the first line. The first line, the y-intercept is +2. So let's go up to the y-axis at +2 and put a point. Now, let's take a look at the slope. The slope is 3. Okay, so if this slope is 3, that means rise 3, run 1. Okay, so rise 3, run 1. Now, I can do the reverse to get some more points, going down 3 to the left 1. And there's my first line. Okay, all right. So now let's graph the second line. Your y-intercept here is -2, so we're going to go down to -2 on the y-axis. And your slope is +3. Well, that's the same slope that we just did, right? So we're going to go up 3 over 1. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Okay, well, I'm out of room here. Let's see if I can go in the reverse direction, so down 1, 2, 3 to the left 1. Okay, now let's go ahead and connect those points. Well, in each of the previous examples, I got that the lines crossed. But in this example here, do they ever cross? Like, even if we kept going forever and ever, you know, in this upward direction, or we kept going downward, are they ever going to start to tilt so that they intersect? It doesn't look like that, right? Okay, so why is that happening? Well, first of all, what do we notice about the slope of the two equations? Yeah, these two slopes are the same, okay? So they are the same slope. Okay. Now, what do we notice about the y-intercepts of the two lines above? Well, are they the same? Well, yeah, both 2, but one's negative, one's positive. So does that really mean they're the same? No, they're not the same. They're different, okay? So we notice that the y-intercepts are different. Now, because the slopes are the same, but the y-intercepts are in different places, this creates a special type of line, a special type of set of lines. Does anyone remember what kind of lines these are? Give you guys a hint, it starts with a P. Okay, they are called parallel lines. Okay. And one thing that hopefully you guys have learned about parallel lines in the past is that they are never going to intersect. Parallel lines do not intersect. Okay? So, if these two lines are parallel and they're never going to intersect, how many solutions does this system have? Does it have a solution? Does it actually have a point where it crosses? No, it doesn't. Okay? So what we write down for our answer in this one, since we don't have a solution, is we write down that there is no solution. Okay, so we can't actually write down an ordered pair because there is no ordered pair where they intersect. This is considered no solution. Okay. All right, let's go ahead and take a look at the last example on this side. Let's look at example 4. Okay, so example number 4. Let's go ahead and graph these two lines. So this first line, your y-intercept is 3, so let's go up to 3, put a point there. Now, what's your slope here? Well, your slope is negative 3/4, so that means down 3 to the right 4. So down 1, 2, 3 to the right 1, 2, 3, 4. Now I can't continue that path, that direction, but let's see if I can go the reverse, up 1, 2, 3 to the left, 1, 2, 3, 4. So I can fit one more point there. All right, let's go ahead and connect. Okay, there we go. Now let's take a look at the next one. The y-intercept is 3, so let's put that on the graph, 1, 2, 3. And your slope is also negative 3/4. So same slope again, down 3 to the right 4. Now what's happening here? Since I have the same y-intercept and the same slope, what is happening when I graph my second line? Well, yeah, it's the same line, right? It's right on top of the other line. Okay. So let's go through and answer some of these questions here. Okay, what do we notice about the slopes of the two equations above? Well, the slopes right here, they are the same, right? Now, what do we notice about the y-intercepts? Well, in this particular one, okay, let's take a look at what the y-intercepts were. It was this number and this number. What do you guys notice about those? Yeah, they're the same. Okay, so when we have this situation happening, we have two lines that are in the exact same place on the graph. They're basically overlapping each other. So how do we say what the point of intersection is if these lines are overlapping? Well, aren't there many, many, many points that they're touching each other or where they're crossing, right? They touch here, they touch here, they touch here, they touch here. I mean, I could keep drawing a bunch of tiny points and continue in this pattern for forever because they're overlapping each other, right? So how many solutions does this system have? It doesn't just have one, it actually has infinitely many solutions. Okay, so that's what a system looks like that has infinitely many solutions because every single point on this line is a solution because the two lines overlap. All right, so if you're done with this side, let's go ahead and flip over to the back of your notes page. Let me find the back of mine. There we go. Okay, so let's review some key points here. Okay, when we're graphing systems and we're solving by graphing, we have three different possibilities. Okay, we could get one solution, no solution, or infinitely many solutions. So let's go over some of the key things that happen when we get one solution. Okay, one of the things that happens is that the slopes are going to be different. Okay, the y-intercepts are usually different, but they could be the same. Okay, and the lines end up where they intersect. So we get intersecting lines. Okay, now the intersection that takes place when it's one solution, this is a point. They only intersect in one spot, and this point has an x and a y value that we can give an ordered pair to. All right, so let's look at what happens when there's no solution. Okay, when there's no solution. Well, what did we learn about the slopes of these two lines? What was happening with the rise and the run in this line and the rise and the run in that line? Yeah, they were the same. Okay. Now, what did we learn about the y-intercepts? This y-intercept here and this y-intercept here. Well, yeah, they're two different y-intercepts, so they must be different y-intercepts in order for them to be a no solution. Okay. Now, this special type of line, just to review, what kind of lines were these? Remember, it started with a P. Yeah, they were parallel lines. Okay. And is there actually an intersection of these two lines? No. So there's none. Okay, the intersection doesn't happen. All right, so last, let's look at when we have infinitely many solutions. Okay, when we have infinitely many solutions, the slopes of these two lines, they're the same. What about the y-intercepts? Are those in the same spot? Yeah. Okay, now these two lines, they are basically the same line, or we could call them overlapping. And what type of intersection do we have? We have many points of intersection. Okay, actually an infinite number, right? So we have many points of intersection there. All right, so what I'd like you guys to do right now is take a couple minutes to discuss with your groups what you think the answer to each of these is. 1, 2, 3, 4. So you're going to fill in a sentence that would complete each of these that would make sense from what we've learned already. Okay, so I just want you to do this part right now and then wait, and we'll go through the bottom in just a minute. Okay, so let's review what you guys kind of filled out here. Okay, hopefully you wrote down that a system is a set of two or more equations with the same variables. Okay, so hopefully you wrote something to that effect. If it wasn't exactly like that, but it's kind of the gist of it, that's fine. If you need to fill some of this in, go ahead and do that now. Okay, so let's take a look at the next one. A solution of a system of linear equations is a point, or it could sometimes, like in the case of infinite solutions, it could be the set of points, where the equations intersect or overlap. Okay? All right, let's take a look at the third one. No solution means the equations never cross or intersect. oops, never okay. Some of you might have also written that they are parallel. If you wrote something like that, that's fine as well. Okay. All right. And then the last one, a system of equations has infinitely many solutions when the lines are the same. Okay, so hopefully you've got something kind of similar to what we came up with here. Okay. All right, so now what I'd like you guys to do is take a minute or two and discuss with your group members how you would summarize the process of solving a system of linear equations by graphing. So basically, how do you solve by graphing? Write a short couple sentences explaining how you do that. Okay? All right, so let's go over what are some of the key points in solving by graphing. Okay, today most of the equations we worked with were in slope-intercept form, so we're going to use our slope and our y-intercept to graph each line. Okay, then we're going to determine the point of intersection if there's any point of intersection. Okay, because remember, sometimes we won't get a point of intersection if the lines are parallel. Okay. All right. Okay, any questions about that? All right.